Welcome to Scholar Opportunity Nexus, and in today's series of videos, we'll be looking at triangle law of vectors. In our previous video, we spoke about addition of inclined vectors, that's addition of vectors that are inclined at an angle. We dealt with the 90 degrees, that's two vectors that are inclined at an angle of 90 degrees. We dealt with this, and we also spoke about the fact that some vectors can be inclined at an angle other than 90 degrees or 0 degrees. And how will we go about these vectors, especially when they are acute angles, that's angles less than 90 degrees? How are we going to add these two vectors together? Something like, say, this is theta, this is a vector a, this vector b, something like this. How are you going to add both of them together? And we spoke about the fact that you could use triangle law of vectors or parallelogram law of vectors. So today we are going to talk about the triangle law of vectors. The triangle law of vectors basically, or in simple terms, states that, and I would use a diagram to represent this. So let's represent the triangle law of vectors using the triangle diagram here. So the triangle law of vectors states that when two vectors that can be represented by both magnitude and direction, that's what one vector represented by both magnitude and direction, the second vector represented by both magnitude and direction, acts at a point such that these two vectors are in the same order. The resultant vector, represented by both magnitude and direction, is the third side of the triangle that completes it, such that these three vectors remain in equilibrium. So taking the law again, when two vectors acting at a point, so two vectors A and B acting at a point are represented by both magnitude and direction. That's what this represented by magnitude and direction. This vector also represented by magnitude and direction. One, they're acting at a point. So when two vectors acting at a point are represented by both magnitude and direction, such that they are in the same order, the resultant vector, the resultant vector that is also represented by magnitude and direction, is the third side that completes the triangle, such that these three vectors remain in equilibrium. So this is going this way, it's moving in the same order. You won't say that because it's moving in the same order, the resultant vector too the arrow would be like this. That won't be in equilibrium, because we know that we are moving. It's like we are moving from here to here. It's like a displacement. So the first displacement was from here to here, then another from here to here. But this is our final destination, and we are trying to find just a single displacement that would cover that distance and will still get us to our final destination. So in that case, you see that we are moving from this point to this point. So the arrow would be like this. And in that case, these three vectors are in equilibrium. Now, when dealing with triangle law of vectors, we have to know some stuff or some things, or some points that we have to know when dealing with triangle law of vectors. Let's go to the next slide. So for triangle law of vectors, let's draw it again. Then you'd see, let's say this is A, this is B, and this is the resultant. Let's say VR. So taking this, see that these are the two vectors, right? So one, before you use a triangle law of vectors, the two vectors must be inclined at an angle. Yes, that's the basic reason why we are learning the triangle law of vectors, because it's an addition of inclined vectors. So one, the two angles must be inclined. So the two vectors, sorry for that. So the two vectors must be inclined. So yes, the two vectors must be inclined and they must be represented by what? Both magnitude and direction. Must be represented by both magnitude and direction. And also these three, like the three vectors must be in equilibrium. That's the vector must be in equilibrium. The three vectors, including the resultant vector, must make these three vectors in the triangle be in equilibrium. And you know that first, with that said, for it to be in equilibrium, vector A and vector B must be in the same order. They must have a sense of like same direction. So you see this is moving from here to here, and then B takes over moving from here to here. It's like this is the final destination. This is the starting point. So this must have a sense of what um, direction, same direction. Now that we know this, we have to, so finding the resultant vector. Previously, we learned about the sine and cosine rule. Assuming you are given this magnitude to be 6, this magnitude to be 7, and you are asked to find this, we can actually use the can use the sine rule or even the cosine rule to be specific. That's what the cosine rule that says V. So VR will be equal to the sum of the two vectors square. So V square minus twice the product of the two vectors cos of the angle between them. Cos of the angle between them. So mostly the cosine rule is used when solving this.
So when using the cosine rule, when the inclined angle or the angle here is less than 90 degrees, you would maintain this sign. But when the inclined angle or that angle is greater than 90 degrees but less than 180 degrees, you'd the formula will now be V VR equal to A square plus, which my laptop is like, plus 2A. So the sign here changes to plus when the angle is greater than 90 degrees and less than 180 degrees. Yes, yes. Because when using, we know that 90, like using these trigonometric quantities, these two angles, so cos of an angle less than 90 degrees would be equal to, would be the same as the negative the cos of the angle supplementing it. That's the angle that would add up to it to make 180 degrees. So in that case, over here, you would get you would have gotten a negative answer here. So that negative multiplying the negative here would give you positive in that case. That's why here is positive when the angle is between 90 and 180 degrees. That's if it's greater than 90 and less than 180 degrees. So that will be it for triangle law of vectors. In our next video, we'll be talking about parallelogram law of vectors, which is similar to the triangle law of vectors. We'll look at it and look at how we can explain it for a basic person or someone to understand basically. Thank you very much for watching this video, and I hope to see you in our other videos.